Welcome to Biology My Passion. I am Soumya Harikrishna. We are learning the chapter Metals and Non-Metals. In the previous video, we learned how the metals are reacting with the different substances. For example, we learned reaction of metals with oxygen first, then reaction of metals with water, reaction of metals with acid, and a reaction or displacement reactions. Metal A in a salt solution of metal B, how it displaces the less reactive one from its solution. So these four reactions we learned in the previous session. Now we will see the reactions of non-metals. So first is non-metals, when they react with oxygen, what happens? Of course, non-metal oxide will form. For example, carbon is a non-metal. When it combines with the oxygen, we get carbon dioxide, which is a non-metal oxide. But these non-metal oxides are usually acidic in nature. We learned metal oxides are basic in nature, non-metal oxides are acidic in nature, but sometimes a few are neutral also. So, a non-metal oxide, if reacts with the water, for example, the carbon dioxide that we got, if it reacts with the water, we will get acid. What is this acid? H2CO3. H2CO3 is a carbonic acid. Rainwater contains small amount of carbonic acid. Or if it is another non-metal oxide like sulfur dioxide, if it combines with the water, we get H2SO3, sulfurous acid. Usually, non-metals react with oxygen to form non-metal oxides. The second reaction is non-metals with the water. Usually, non-metals do not react with the water because they cannot displace hydrogen from water. So, there is no reaction happening. Now, we will learn about ionic compounds. Now, we will learn ionic compounds. We know when a metal, that is metals are electropositive, they are ready to give electrons. If those electrons are accepted by a non-metal, they can form a bond. In this case, the metal by losing electron becomes a cation, that is electropositive we say. The same way non-metal becomes negative by receiving an electron, anion. So this bond is called a ionic bond. But in carbon compounds we learned sharing of electrons, the bond is called a covalent bond. So we will see now how ionic bonds are forming in these compounds. Let us now take the example of sodium chloride. Sodium chloride is formed by sodium and chlorine. So we know that sodium is a metal. Okay, what is the atomic number of sodium? I have told you up to 20 you have to by heart. So sodium is a 11. So what is the electronic configuration? If you see K, L, M, N shell, first shell maximum 2. The next shell 8. So 8 plus 2 10. Then now 1 is left. The same way if you take chlorine. Okay, so chlorine, if you say chlorine, the atomic number is 17. So if you write the electronic configuration, K shell will have 2, L shell will have 8. Now how many left in M shell? 7. So here you can see that sodium, if it leaves this one electron, the previous shell will complete the octet, so it is satisfied. Whereas chlorine needs only one electron to satisfy this outermost electron. So chlorine will receive one electron, sodium will give one electron. So in that case, suppose if I write sodium 2, 8, 1, what will it give? It will give sodium plus leaving an electron. So when it is leaving an electron, what happens to the number of electrons? The number of electrons will become 10 only because one electron is lost. But what happens to the number of protons? It remains the same, 11. So 11 positive charges and 10 negative charges means what? 1 plus charge is the net charge. So that is that plus charge that sodium is attaining. As a result, the sodium becomes a cation. Okay? Means positive charged ions are called cations. Now if I look at the chlorine atom, chlorine, it is 2, 8, 7, but it is accepting one electron. So by accepting that one electron, chlorine becomes Cl minus. Why? Because here now accepting one electron, the total number of electron becomes 80. But what happens to the number of positive charges or the protons in the nucleus? It is remaining the same, 17 only. So 17 positive charge and 18 negative charge. So what will be the ultimate charge? It will be minus 1. So that is why it is gaining a minus 1. So this is chlorine anion. Now we will see how they are sharing electrons. For showing that electron dot structure, we have to show only the valence electron. So sodium, there is only one electron in the outermost shell, that is given as a dot here. Whereas chlorine, I am showing us into mark just to demarcate between these two. 3, 4, 5, 6, 7 actually were there. Now this one will go here. Right? So as a result, what we are getting is sodium chloride. That is Na plus and Cl minus. So this is the molecule of sodium chloride. Now let's see the formation of another ionic compound, magnesium chloride. Here magnesium is a metal, chlorine is a non-metal. Magnesium has atomic number 12. So the configuration is 2, 8, 2. Outermost shell 2 electrons are there. So it will lose those 2 electrons. Whereas chlorine is 17, just now we saw it needs 1. So here magnesium is giving 2, but can chlorine take 2? No, only 1 it needs. So 2 chlorine atoms can take 1 each. So here we will see magnesium becomes magnesium 2, 8, 2 becomes Mg2 plus 2, 8 plus 2 electrons. Since 2 electrons are lost, now the total number of electrons become 10. Whereas the number of protons are still 12. So the net charge is plus 2. That's why 2 plus it became a divalent cation it became. Whereas chlorine, if you see 2, 8, 7 plus 1 electron, it will become Cl minus 288, which is an anion. This is cation. Okay, now we'll see how it is forming the molecule. For example, if I draw Mg, it has got 2 electrons in the outermost shell. We are showing only the valence electrons. Whereas chlorine 1, 2, 3, 4, 5, 6, 7. Another chlorine 1, 2, 3, 4, 5, 6, 7. So from here 1 electron will go here and 1 will come here. So both the chlorine will take 1 each. So as a result, what will we get? Mg 2 plus we will get, because it has received 2 positive charges or it gained 2 positive charges, whereas chlorine is 1, 2, 3, 4, 5, 6, 7, 8 minus but 2 chlorine molecules. So what is the formula of magnesium chloride? MgCl2. So this is another example of an ionic compound, magnesium chloride. These two from the textbook, the same way. Practice as many times as possible, especially this one or isomers of carbon compounds, all these cyclohexane, benzene and all, you have to by heart it, practice and by heart. So as and when it is asked, you can just write it in the answer sheet. It's very important. What are the main features or general properties of ionic compounds? First of all, ionic compounds are solid because the force of attraction between the cation and anion is very high. So these molecules are very difficult to break and they are generally brittle and break into pieces when pressure is applied. The next is melting and boiling point. They have high melting and boiling points also because considerable energy is required to break the bond between them. Next is about solubility. So they are generally soluble in water and insoluble in solvents like kerosene, petrol, etc. Conduction of electricity, if we talk about, the conduction of electricity involves the movement of charged particles. We know that ionic compounds in water contains ions. They can move to opposite electrodes when electricity is passed through the solution. And in solid state, they will not be able to conduct electricity because they are not in the ionic form. Molten state, it can have ions so that it can carry electricity also. So we can say that ionic compounds in molten state can conduct electricity. Hope you are enjoying my lessons. I would like to know about your experience through the comment box, and also please like, share and subscribe to my channel Biology My Passion. Thank you for watching.